derive an expression for exhaust velocity as a function of mass. So doing this, here's a rocket with a exhaust velocity, VE. So that is actually going to be negative because it will be leaving the system. And then we can define our system by doing a differentiation of the mass times volume of rocket with respect to time. And the things we're going to consider in this particular equation is mn, vn, and then subtracting our m out, v out. So once we integrate like this, we're going to be able to set the problem equal to 0. So doing so, our mn, vn is going to be able to break apart as mr dvr over dt plus our vr dmr over dt. And then our m out is going to be our difference in velocity, so our rocket velocity once at the speed minus the exhaust velocity. And then we differentiate according to mass over time. So as I said, once we do both of those, we can set this equal to 0 and begin to solve. So I'm going to distribute this and set it equal to this. So that's going to be VR dmr over dt minus our exhaust velocity times the same here. Now we can do a couple of things. We can actually just get rid of all of our dt's because they all end up being the same. And then we can subtract our VR from both sides here, and they will cancel as well. So get rid of those. And then what's left is here and here. Pulling those down here, we actually can just move this mr over to the other side to make it able to integrate. So that's going to look like dvr is equal to negative VE dmr over mr. All right, so from here we integrate. I'm going to put the integration here because we know that that will be a constant. Then we define our limit as starting from a 0 velocity and then going up till rocket velocity. And then we define starting mass as given in problem as mi and ending as mr. So this is a simple integration. It ends up being ln. So we can, and then this is also simple, it's just VR. So we get VR from 0 to VR, so that'll just be VR, is equal to negative exhaust velocity times the natural log of, and then with logarithmic principles, you can do mr over mi. And then to distribute this and make our equation a little bit more consolidated, we can call VR being equal to, VE ln of mi over mr. And that will be our final equation. All right.